The difference between the past and the present, that is evolution. Measure it however you like, in gene mutations, in life expectancy, in technological breakthroughs, in happiness and harmony, in productivity and freedom. We've changed, and so has the world around us. And now, the need is greater than ever before. There are too many people and too few resources. The way we power our lives is unsustainable, and our modes of transportation need to be reconceived. The machine minds that we created to fuel the great innovations of the last century might be the biggest existential threats of this century. Evolution is coaxed along by nature, of course, but also by dreamers and visionaries who see possibilities where others see problems. Men and women who disrupt patterns, shrug off the status quo, and forge our future at the intersection of imagination and ingenuity. We must evolve. This is one man's vision of the challenges fueling our evolution. Come see what that tomorrow looks like. It used to be simple. Heat made energy. It kept us warm, it cooked our food. We figured out how to burn other stuff to power our lives, but we were polluting our planet. Then, we started running low on things to burn. So, we made power without fire. Then, we made it out of things you couldn't see. Problem is, these new solutions are real, but none of them are without consequences.
I think that the biggest problem that Earth faces this century, or has to be solved this century, is sustainable energy production and consumption. We've got to make electricity in a sustainable way. Modes of transport need to be primarily electric. That's, my opinion is, we either solve that this century or there will be huge economic collapse towards the end of the century, independent of any environmental impact.
There used to be fewer of us. That's the thing about humans. We were kind of born to breed, and we breed a lot. Then, we found solutions. But like most solutions, they come at a cost not everyone can afford. So governments step in, and cultures change. Corrections occur. But that doesn't change the fact that because there are so many of us, and so few resources, there aren't always enough to go around.
We should be concerned about demographic implosion.
Why do you say that?
So if you look at countries like Japan, most of Europe, China, and you look at the birth rate in a lot of those places is only at about half of the sustaining rate. When you have an inverted demographic pyramid, so if you look at the pyramid and you've got age variation, 60-year-olds, 50-year-olds, 40-year-olds, 20-year-olds, like sort of a demographic pyramid.
Right.
And in some countries, it's like an upside-down pyramid, so it'll sort of fall over. It will not stand. What we'll actually have in those countries is a very high dependency ratio, where the number of people who are retired is very high relative to the number of people who are net producers. And so you cannot, the social safety net will not hold. We didn't evolve for this because we sort of evolved to just always procreate, and there wasn't birth control or anything.
Right.
We just like have lots of babies. It's like pop the course, and like hopefully some of them would survive. That was like all of human history until very recently. And now it's you've got cases like Japan where adult diapers outsell baby diapers. Europe's in a similar situation. China's headed the same way because they've had the one-child policy, and then even though they've relieved the one-child policy, the social norm has become to have an average of one kid. So even when they relieved that requirement, it didn't change. You can imagine, like people sometimes say, well, what about immigration? It's like, okay, look, there's 1.5 billion people in China. Where is China going to get 700 million new people? Okay, that's like 3 Indonesias. It's like, it doesn't work. And the full gravity of this is not well understood, but will become a severe issue in the next few decades.
You've heard the saying, time is money, and it is. Perhaps that's why we complain about travel. How can we get there faster? Can this experience be better? We dream about moving comfortably from place to place in the blink of an eye. That's essentially the dream of the Hyperloop. What exactly is the Hyperloop?
It's very similar to an airplane on high altitudes. You have a low pressure environment inside the tube, a capsule that doesn't touch anywhere, hovers, and then because of the low pressure doesn't encounter a lot of resistance.
How do you envision the Hyperloop changing the way we live?
To connect two major cities that are normally 6, 7, 8, 9 hours apart within 15 to 30 minutes changes the way we live. We're living in areas that are completely overfilled. We're sitting in traffic every single day for hours. So
And you think the Hyperloop could be the solution?
I think the Hyperloop is for sure one of the solutions.
A possible solution, maybe, but it's far from a reality. This concept of humans traveling around in tubes has been around for more than a century. Then, in 2013, Elon Musk drafted up actual blueprints and put the challenge of building it to the engineering community. And, as it turns out, there were a few willing to try. Hyperloop transportation technologies took on the challenge, but quickly realized they didn't have the design expertise. Enter UCLA.
The engineering aspects of this, they're actually quite simple. It's really the design that is the most technically challenging.
What's so challenging is it's an unconventional system. And so you sort of have to invent everything from the ground up. The track is an entirely different element. The station is entirely different. The process of boarding is different. So as architects, what we're trying to do is stitch together the technology, the social change, and the human experience.
So do we know what it's going to feel like to be traveling at 700 miles an hour in one of these tubes?
You'll accelerate.
And you'll feel that physically.
You'll feel that as a thrust, like a very fast, powerful car, like a Tesla. You will feel almost no sense of motion once you're at speed. You're mainly going to experience getting there and stopping.
Each year, this UCLA grad program takes on a big problem and tries to solve it. The Hyperloop's biggest problem? Making tube travel comfortable.
So this is kind of like the Hyperloop think tank
Yes,
design
yes.
center right now. What are these models over here?
So we have two sets of models. The first ones here at the back, they were really study models that were investigating. These are more of a finished product that investigate more of the interior situation and also the sitting.
So these are all the options of the capsules.
Of
What
the
about
capsule.
the stations here?
So same thing with the station. This station is probably the most compact station, and it really, the entire activity actually happens almost here. This is more still of a lounge shopping area.
this is where you get your magazines,
Yes,
your coffee.
but still everything happens on the go.
This one looks very complicated here.
Yes, it is maybe not as complicated as it is grand. The students were really inspired by Grand Central Station, and this station really is able to hold 6,000 passengers.
6,000 passengers?
Within 1 hour. But the idea is not to be in the station, at the station for an hour. This is the interesting one because it uses a very different system. You come here on the road system, you're dropped off, and this is in a way your pod. So you need to know with your phone probably
It's
which...
almost like your terminal. Which
Yes,
one
this
you
is
get,
your terminal.
Which one you get dropped off
Yes.
at. You're traveling at speeds of hundreds of miles an hour. How could this possibly be safe?
In railroads, most accidents were all human factors. So we're in a closed system. We're completely managed by a computer system. There's no human factor that can actually create those issues.
How much money have you guys raised here?
Zero.
How are you going to get this off the ground?
Innovation is done in teams. It's not done by a single person.
Do you feel like you're working on a project that's really going to change the future?
Oh, absolutely. If I have a date and I want to see the opera in San Francisco, I can literally do that and be back in time to go to sleep at my own house. I mean, that's the nature of the kinds of disruptive change that this can bring in. To be able to be part of this effort is a dream come true.
In the beginning, it was about instinct, moving from place to place. Initially for survival, then to pioneer. Today, we travel because we can. On vacation to business meetings, from point A to point B isn't just a car ride. It's a train, it's a plane, and soon even a space flight away. But what about efficiency? There's a gap between imagination and actualization.
You can go anywhere on Earth, anywhere. Like, you can actually go to, like, the top of Mount Everest. There's no place you can't go, anywhere. So I think we've explored the boundaries, at least the physical boundaries of Earth, quite thoroughly.
You're describing how we can go anywhere on Earth now, but the methods with which we use to get there, do you think they're efficient?
The most important thing that needs to happen is the transition of transportation to electric. The ideal long-distance transportation mechanism is a supersonic vertical takeoff and landing electric jet. And then there's a special case of cities which have a lot of travel between them, below about 500 miles of distance, where I think the Hyperloop would be useful. It is a special case solution because once the distances get long, then the amount of time that an aircraft takes to ascend and land, which is most of what it does in a 500-mile trip, that percentage declines, and then it's better to just use aircraft. I know that there are various companies that are trying to create the Hyperloop, and honestly, I think it's a lot easier than people think.
The blueprints are pretty complicated.
Well, blueprints are always kind of complicated, and I mean, yes, there's math, but it's really not that hard.
It still sounds pretty complicated, Elon.
It's like a tube with an air hockey table. It's just a low-pressure tube with a pod in it that runs on air bearings, on air skis, with an air compressor on the front that's taking the high-pressure air buildup on the nose and pumping it through the air skis. It's really, I swear, it's not that hard.
Computers were invented out of necessity. They do things faster than we can. In America, nothing is stronger or faster than a supercomputer named Titan.
Why do we need a supercomputer?
The supercomputers that we have today are really addressing some of the most important problems that we have in the world. They just can't be done on smaller computers. In fact, we need more powerful computers to address fully all of the science that we want to be able to accomplish.
And what kind of problems are we talking about here?
We're tackling all kinds of problems in the energy space. We're also looking at basic materials problems. How do you keep materials from aging? We're working on things like fuel economy, everything from how the universe formed down to the smallest nanoparticles.
Can you compare the power of a supercomputer to, let's say, my smartphone?
It would probably be 10 million times more powerful than what you can do with one smartphone. It's more powerful than any other computer that's available to the open science community in the world.
It's powerful because there are a lot of computers working together to achieve one goal. Check out all of these towers. When stacked together, they have the capability of completing 20,000 trillion calculations per second. Translation: researchers will be able to utilize that computing power in order to have more scientific breakthroughs.
Walk me through how this works.
Each circle is going to be what we call a neuron. The neurons are connected to each other. We have different layers of neurons, and each layer is going to do something different to the data.
And this architecture, this is how you're trying to mimic the brain, how the brain processes information.
This is the a current approach to mimicking how the brain processes data. With Titan, the advantage that we have is we actually can run multiple designs in parallel to try to find the right design that works best.
Is this the kind of computer that we should be scared of?
I love science fiction movies, and I've seen all of the ones, with computers taking over the world. We're a long, long ways from anything like that happening. I think we should look to Titan and other machines like it as the best tools that we have to do science to help the world.
Intelligence is the ability to understand. We've always had it. We've passed on what we know to each other and to machines. We've tried to recreate it through codes and robotics. We've yet to master it. But here's the question: where is the line between the man and the machine?
AI is much more advanced than people realize, and the pace of progress is much greater than people realize. It'd be fairly obvious if you saw a robot walking around talking and behaving like a person, and be like, whoa, that's like, what's that? That would be really obvious. What's not obvious is a huge server bank in a dark vault somewhere with an intelligence that's potentially vastly greater than what a human mind can do. I mean, its eyes and ears would be everywhere. Every camera, every microphone, every device that's network accessible. That's really what AI means. It's not like a robot running around. The robots would simply be, they'd be like a finger of the AI.
So you yourself have invested in some AI companies like DeepMind and Vicarious.
Yeah.
Why?
I invested in those companies to keep an eye on them. I wanted to see how artificial intelligence was developing. If we're not careful about the advent of AI, it's possible that there could be what's called a bad utility function. A computer will do exactly what its goal is. Humanity's position on this planet depends on its intelligence. So if our intelligence is exceeded, it's unlikely that we will remain in charge of the planet.